This is such a nice little lesson because it uses geometry to make sure that you have parallel lines. And how often do you need parallel lines in design and building and things like that? So these are some techniques that you can use to make sure that your lines are parallel. The first way we'll talk about uses corresponding angles to make parallel lines. This is a postulate, and it's called the corresponding angles converse. It says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines will be parallel. If you don't use corresponding angles, you could always go with alternate interior angles. If we can make those alternate interior angles congruent, then you'll know that the lines are parallel. That's called the alternate interior angles converse that guarantees that. Can you guess what comes next? The alternate exterior angles converse is a theorem that says as long as you make those alternate exterior angles congruent, you can be assured that you have parallel lines. And finally, the last theorem, consecutive interior angles converse, could call it same side. If you can make sure that those same side interior angles are supplementary, then you'll know for sure that you have parallel lines. Remember that the theorems from last time said if you already knew you had parallel lines, then you could say that your angles were congruent or supplementary. These converses, if you remember, a converse is where the if and the then switch. So in this case, we'll be checking to make sure if our angles are doing the right thing, then we can guarantee we have parallel lines. That's the difference in today's lesson. I really want you to be able to tell the difference between the postulate and theorems that we learned last time and those that we're learning today. So these are the theorems, postulates, that prove that angles are congruent. So the ones that we learned last time, you would only use those if you were given some parallel lines. That's the only time you're allowed to use any of those. And the reason that you would use those is if you were trying to tell us something about some angles being congruent, right? The converses of those are going to be used if you have a diagram and you're not sure if the lines are parallel, but you have some information that's given about some angles. If you know something about the angles and you're trying to show that, yes, I have parallel lines, then these are the theorems to use, the converses. In this example, we're looking at the flag of Nepal, which has an interesting shape, and we're trying to see whether those two sides, those two bottom sides right here, are parallel to one another. And what I can see on this diagram is that they've measured some angles for me. They measured this angle right here and this angle right here, and they were congruent to one another. If those angles are congruent, we can tell that the sides are parallel. What type of angles are those? We're looking at this side of the flag as our transversal. If we extend that, it might be a little easier to see that those are both interior angles. So we would say because the alternate interior angles are congruent, then we know that the sides of the flag are parallel. Our conclusion is that we have parallel lines. If we were given this information, could we say that lines A and B are parallel to each other? It's not enough just that they look parallel. They don't have the markings on them. But given this information, would that be enough? I would say yes, because angle 1 and angle 2 are those same side interior angles. And if we know that they are supplementary, then we can say that those lines are parallel. What theorem or what postulate did we just use? We were talking about same side interior, so it's the same side interior angles. But is it the theorem or is it the converse? And the way you can tell is what you're given versus what you're trying to conclude or what you're trying to prove. And we are trying to prove that these are parallel. So if we are given something about the angles and we're trying to show that the lines are parallel, that's the key that we are using a converse. This one says to write a paragraph proof. We've never done this before. I had you try a little flow proof, and we've done those 2-column proofs mostly. This is called a paragraph proof, It's a little harder because you have to make sure that those statements have reasons with them. So let's try this. What is the given? In the figure, A is parallel to B. I'm going to mark those givens. A is parallel to B, and angle 1 is congruent to angle 3. That's our givens. And we are going to prove that line X is parallel to line Y. Since we're given those parallel lines, we should probably be able to say some angles are congruent, right? Should we use X or Y as the transversal? I'm thinking if we use X as the transversal, do you see what kind of angles 1 and 2 are in relationship? Those are corresponding angles. So I can say that since A is parallel to B, then angle 1 is congruent to angle 2 by the corresponding angles postulate. I was proving that the angles were congruent. And our other given was that angle 1 was congruent to angle 3, and we just showed that angle 1 was congruent to angle 2. Then we can say angle 2 is congruent to angle 3 by the transitive property. Angle 2 being congruent to angle 3 is a big deal, because now we can sort of ignore line B altogether. Angle 2 and 3, we don't need to look at line B. If those two angles are congruent, can't we say that these lines, X and Y, are parallel to each other? But we have to back up every statement with a reason, a postulate or a theorem. How do we know that those lines are parallel? I would say that looking right here, we've got exterior angles, right? If we're looking at lines X and Y. So those would be alternate exterior angles. Am I looking at a theorem or a converse? Well, you can tell in this sentence that I was starting with the angles being congruent and saying that the lines are parallel, so that tells me I'm using the converse. And that's a paragraph proof, and we just kind of wrote it into words instead of just having those two columns. Last little theorem probably will seem pretty obvious to you. It says if two lines are parallel to the same line, in this case it says that P is parallel to Q and Q is parallel to R. P and Q are parallel and Q and R are parallel, so couldn't we say that P and R are parallel? It almost seems like a transitive property, right? So they call this the transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Here are some blinds on a window. It says that the first slat is parallel to the second slat, and the second slat is parallel to the third slat.
And the third is parallel to the fourth, and the fourth is parallel to the fifth, and the fifth.
And so on, until the 15th is parallel to the 16th. Explain why the top slat must be parallel to the bottom slat. And we would explain that using the transitive property of parallel lines.